Designing and building an electromagnetic field, or EMF, shielded medical center involves several key considerations. Firstly, room design is critical. Consider Faraday cage construction by installing copper mesh or conductive paint on the walls, ceiling, and floor to create a conductive enclosure that reflects and absorbs EMF. Ensure the Faraday cage is properly grounded to dissipate static electricity and reduce stray fields. Install 2 metal doors with a vestibule between them to prevent EMF penetration. Design the room with adequate ventilation to prevent oxygen depletion and minimize EMF from heating, ventilation, and air conditioning systems. Secondly, regarding equipment, use EMF meters to measure and monitor EMF levels within the room. Install EMF shielding curtains around the exam table or areas where electrical equipment is being used. Choose light-emitting diode lights, halogen lights, or incandescent lights with dimmers to minimize EMF emissions. Ensure all electrical wiring is shielded to prevent EMF leakage. Eliminate all wireless devices, such as wireless fidelity, Bluetooth, and cell phones within the room. Thirdly, construction materials matter. Concrete walls provide natural shielding against EMF. Use metal studs for framing instead of wood to reflect EMF. Choose low EMF insulation materials, such as mineral wool or sheep's wool, to minimize EMF absorption. Use PX or copper piping instead of galvanized steel to reduce EMF exposure from plumbing. Fourthly, additional consideration should be taken into account. Use only essential electrical devices and keep them as far away from the exam table as possible. Inform patients about the EMF shielding measures and their potential benefits. Regularly monitor EMF levels within the room and make adjustments as needed to maintain a low EMF environment. When constructing the Faraday cage, the goal is to create a continuous conductive barrier. Any gaps or openings can compromise its effectiveness. The copper mesh should be overlapped at the seams and securely bonded to maintain electrical continuity. For grounding, use a dedicated grounding rod or connect to the building's grounding system, ensuring a low impedance path to earth. This helps to dissipate any static electricity that may accumulate on the Faraday cage. The vestibule between the 2 metal doors acts as an airlock, preventing EMF from directly entering the shielded room when the door is opened. The doors should have tight seals and be made of a conductive material to maintain the integrity of the Faraday cage. Ventilation is crucial to maintain air quality within the shielded room. Use a filtered ventilation system to prevent outside EMF from entering the room. The system should be designed to minimize EMF emissions from the fan and other components. EMF meters are essential for verifying the effectiveness of the shielding and identifying any areas where EMF levels may be higher than desired. Use a broadband EMF meter that can measure a wide range of frequencies. EMF shielding curtains can be used to provide additional shielding around specific areas, such as the exam table. These curtains are made of a conductive fabric that reflects and absorbs EMF. Low EMF lighting is important to minimize EMF emissions within the room. Light-emitting diode lights are a good option because they are energy efficient and produce very little EMF. Halogen and incandescent lights can also be used with dimmers to reduce EMF levels. Shielded wiring is essential to prevent EMF leakage from electrical circuits. Use shielded cables and conduit to contain EMF within the wiring. A wireless-free zone is important to minimize EMF exposure within the room. Wireless devices emit radio frequency radiation that can interfere with sensitive medical exams. Concrete walls provide natural shielding against EMF because they are dense and contain minerals that absorb EMF. Metal studs are more effective at reflecting EMF than wood studs. This helps to create a more effective barrier against EMF penetration. Low EMF insulation materials, such as mineral wool and sheep's wool, are made from natural fibers that do not emit EMF. These materials also provide good thermal insulation. Non-metallic plumbing, such as PX or copper piping, does not conduct electricity and therefore does not emit EMF. Galvanized steel piping can conduct electricity and emit EMF. Limited electrical use is important to minimize EMF emissions within the room. Use only essential electrical devices and keep them as far away from the exam table as possible. Educating patients about the EMF shielding measures can help to alleviate the concerns and make them feel more comfortable during medical exams. Explain the benefits of EMF shielding and how it can help to improve the accuracy of medical tests. Monitor and adjust EMF levels within the room regularly to ensure that the shielding is effective and that EMF levels are within acceptable limits. Use an EMF meter to measure EMF levels at various locations within the room. In addition to these design and construction considerations, it is also important to consider the following factors: the location of the medical center. Choose a location that is away from sources of EMF, such as power lines and cell phone towers. The orientation of the building. Orient the building so that the exam rooms are not facing sources of EMF. The use of filters on electrical circuits. Use filters on electrical circuits to reduce EMF emissions. The use of grounding techniques. Use proper grounding techniques to minimize EMF. It is important to consult with an experienced architect or electromagnetic shielding specialist to ensure proper design and implementation of EMF-shielded rooms. They can provide guidance on the selection of appropriate materials and equipment, as well as ensure that the shielding meets all applicable regulations. The effectiveness of an EMF-shielded room depends on careful planning, design, and construction. By following these guidelines, it is possible to create a medical center that minimizes EMF exposure and provides a safe and comfortable environment for patients and staff. When selecting copper mesh for the Faraday cage, choose a mesh with a fine weave to provide maximum shielding effectiveness. The mesh should be made of pure copper and be free of any corrosion or contaminants. When applying conductive paint, follow the manufacturer's instructions carefully to ensure proper adhesion and conductivity. Apply multiple coats of paint to achieve the desired level of shielding. When grounding the Faraday cage, use a heavy gauge copper wire to connect the mesh or conductive paint to the grounding rod or building's grounding system. The connection should be made with a secure clamp or connector. When installing metal doors, ensure that they have a tight seal to prevent EMF leakage. Use conductive gaskets or weather stripping to create a tight seal around the door frame. When designing the ventilation system, use shielded ductwork and fans to minimize EMF emissions. Install filters to remove any airborne particles that may be carrying EMF. When selecting EMF meters, choose a meter that is calibrated and certified to meet industry standards. The meter should be able to measure a wide range of frequencies and have a high degree of accuracy. When installing EMF shielding curtains, ensure that they are properly grounded to prevent static electricity buildup. The curtains should be hung close to the window or wall to minimize EMF leakage. When selecting low EMF lighting, choose fixtures that are designed to minimize EMF emissions. Look for fixtures that have shielded components and are certified to meet low EMF standards. When installing shielded wiring, use shielded cables and conduit to contain EMF within the wiring. The shielding should be properly grounded to prevent EMF leakage. When creating a wireless-free zone, remove all wireless devices from the room, including cell phones, laptops, and tablets. If wireless devices are necessary, use wired connections instead. When selecting concrete walls, choose concrete that is dense and contains minerals that absorb EMF. The concrete should be properly cured to ensure maximum shielding effectiveness. When using metal studs for framing, ensure that they are properly grounded to prevent static electricity buildup. The stud should be connected to the building's grounding system. When selecting low EMF insulation materials, choose materials that are made from natural fibers and do not emit EMF. The insulation should be properly installed to ensure maximum thermal and EMF shielding effectiveness. When using non-metallic plumbing, such as PEX or copper piping, ensure that it is properly installed to prevent leaks. The piping should be supported to prevent sagging or movement. When limiting electrical use only essential electrical devices and keep them as far away from the exam table as possible. Use battery-powered devices whenever possible to reduce EMF emissions. When educating patients, explain the benefits of EMF shielding and how it can help to improve the accuracy of medical tests. Provide patients with information about EMF and how they can reduce their exposure. When monitoring and adjusting EMF levels, use an EMF meter to measure EMF levels at various locations within the room. Make adjustments to the shielding as needed to maintain a low EMF environment. Remember that the effectiveness of an EMF shielded room depends on careful planning, design, and construction. By following these guidelines, it is possible to create a medical center that minimizes EMF exposure and provides a safe and comfortable environment for patients and staff. Also, it's important to stay updated with the latest research and advancements in EMF shielding technology. New materials and techniques are constantly being developed, which can further enhance the effectiveness of EMF shielded rooms. Consider attending industry conferences and workshops to learn about the latest developments and best practices. In addition to the physical aspects of EMF shielding, it is also important to consider the psychological aspects. Some patients may be anxious or concerned about EMF, so it is important to address their concerns and provide them with accurate information. Explain the measures that have been taken to minimize EMF exposure and reassure them that the medical center is a safe and comfortable environment. Regularly review and update the EMF shielding measures to ensure that they remain effective. As technology evolves and new sources of EMF emerge, it may be necessary to make adjustments to the shielding to maintain a low EMF environment. Consider establishing a maintenance program to regularly inspect and test the EMF shielding. This will help to identify any potential problems and ensure that the shielding is functioning properly. When designing and building an EMF shielded medical center, it is important to take a holistic approach that considers all aspects of EMF exposure. This includes not only the physical shielding but also the psychological aspects and the ongoing maintenance of the shielding. By taking a comprehensive approach, it is possible to create a medical center that provides a safe and comfortable environment for patients and staff.